constant, and that you have to know this, and it's on exam every year. And exponential growth and decay is on the exam. In particular, this differential equation is on the exam. Now, don't get that confused with dp dt is equal to some constant times t. So you're going to have to not read so quickly, Marcus. Put your phone away, please. And recognize this. So let's solve this. And then we're going to do the waste problem from last year, because it's the same question. And hint, hint, there's a similar question on your test.
Wait.
Hint.
Say that again.
There is a similar question to the waste problem on your test. Not exactly the same.
Wait, are these both partner? Or?
No, they're individual. I don't know. I have to look.
Why do we need to do the test?
Yes, we do. Okay, so we need to solve that differential equation. Now that's an easy one. This shouldn't be a problem to solve. This one? Well, you should know what the answer is without even doing any work, by the way. Do you recognize this? This is PERT. So it's P equals P naught e to the k t.
We have it on the
Yes, you do. It's 7.4, I think, or something. I don't know.
It's 20.
Wait, the logistic one?
No, it's the one right before the logistic one.
Exponential growth. Decay.
They can ask you to solve the differential equation. They can give you a question where they give you the differential equation, which ones of these, which one might be a solution. They can do that. They can ask you to find the k value if you know that the population doubles in 10 years. Do you remember how to do those?
No.
Just to take a little side note, if the population doubles in 10 years, then what's k?
5.
Okay? If the population doubles, you recognize this and say just PERT. There's other ways you can solve, but if you're looking for time, you go, oh, it's just PERT. 2p naught equals p naught e to the k times what? Yeah.
From Janet Swichikowski. Thursday, April 26th, 4 p.m. to 5 p.m. Should we view or close?
Close. I don't know what it is.
Whoa.
I think Mrs. Hersman has them all, but there aren't that many. You can just take notes. Okay, what happens to p naught?
They cancel.
They cancel. So 2 is equal to e to the 10k. How do you solve for k? Log. And actually, you know, that's what the doubling is. You always get the log of 2. And what happens to 10k? Goes down. So what's k equal to? K equals the log of 2 divided by 10. Okay, Matt?
Yep.
I'm not sure you're with me. So how do we solve this equation to get PERT? So you guys need to do this. First, we always cross multiply and get all the same variables on the same side. So dp equals kp times dt. Now what do you want to do? Well, that's a good question. Which side? What's the easiest side to leave the k on? Leave it. Leave it on the t side. You can put it over here, but then I have to worry about the chain rule when I integrate. So why not just divide by p? So dp over p is equal to k dt. And now what do? Integrate. K is a constant. That's right. It's important to realize it's, although if we are talking population, obviously population's positive, equals kt. Now this is what we stressed last week on Friday. What has to happen next? Matt, do you remember? We have to add our constant in now. Some of you will solve for p and say later on add in the c. Well, it's wrong. It's not going to work. So you have to put it in right after you integrate. You get a point for the separating. That's 1. Good. And you get a point for integrating, because the right side's easy. And a 1 point for adding c. And if you don't add c, you're done. You get 2 out of 5 points. You're done. If you don't separate the variables, you get 0 out of 5 points.
You don't do this, so one more point worth, then you get a
Yeah.
And then for, well, we would find C. So if I had the initial conditions that when T is, when T is equal to 0 and the population is equal to P naught, whatever number that is, who cares what it is, then I will substitute that in, because I like to find C right away. I found out after all the years of doing this, it's just easier. And that's equal to K times 0 plus C. You could solve for P, but you guys aren't that great at it, so you're better off with the constant in there. So the log of the absolute value of P is equal to KT plus the log of P naught. Okay, Matt? You said you lost the connection.
Yeah.
So you're not obviously doing math. Well, you could log back in. I know sometimes it just doesn't work. Okay. How do you find P? Raise it. There we go. Now I can control it. Oh, wait. Let's see if I can do this. Let me do that. Okay, so now P is positive, so I can ignore the absolute value. So it's e to the kt. It's hard, isn't it? Plus the log.
I can do it.
Oh, sorry.
You can maybe do it better than me. I don't do it very well.
That's what I'll do.
Yeah, this time do it though.
I have that. What do you want me to write?
Well, I just wrote that's so bad. He's good. Sorry. It's a little okay though, because tomorrow we're going to get into carrying, not tomorrow, Wednesday we're going to get into carrying capacity. What do you guys think? No. Matt, that's what everybody does wrong.
Who's better?
Theirs is beautiful, but it's wrong. Where does this have to go? Whoops.
You said
No, you can't bring this down. That's up in the exponent.
It goes up.
So this you can't put this here. It has to be plus log of P0.
e to the kt times e to the p. Yeah, I was writing what you were writing, but I didn't.
No, mine's up in the exponent.
I didn't.
So what does that end up doing? I'll see it. Play that.
Like the quotation.
Okay. Okay, that's what I saw as a reader. I saw many students doing exactly what Matt did. I know it makes it easier, but it's wrong.
We're just so stressed by time.
So Matt, what do we get? Now, by the way, if you don't know what to do with this, just leave it like that. You don't have to simplify that, but you should be able to, at least I hope. P is equal to e to the kt times e to the log of P naught. Okay? What is that then? What is this simplified to be?
Oh, peanut. Peanut.
Yeah. And there it is. That's PERT. You really should be able to recognize it now. You've seen it for a couple years and, within calculus, so you should be able to do that. Let's see what the next slide says. Okay. Oh, one last limit. Anybody remember that one?
Oh, that's.
I know.
Okay. Kevin, do you remember that limit?
I do.
Justin's got it. E.
I got it. Got it.
Justin Bader.
Okay, in your special place in your notebook, something to review the night before the exam, that's one thing right there. You need to know that that's E. And we're going to do the waste problem. We're going to do the waste problem in class. Now you guys, when we finish up with this, you're only going to have about 2 weeks left. You need to be working on AP material outside of class. Okay, Matt? So let's bring up the waste problem. I'm going to give you a chance to try it, and then we'll reveal answers. Last year's problem. And you guys walked out of there last year saying, there's no T in this problem. Guess what? It's PERT. So it's got a W minus 3. Forget the W minus 300. It's PERT. So let's give it a try. This is last year's problem, number 5. Okay, Matt?
Yes.
So Last year's problem, number 5.
Hold it out. See if I've grown any.
No, that's not going to work. Oh, there it is.